Hey everybody, I'm here again with a solution to another one of these problems here. We have, in this problem, Mr. Vanderglass throwing a baseball straight up into the air. That baseball has a hang time of 6.25 seconds. Determine the height to which the ball rises before it reaches its peak. The time to rise to the peak is 1/2 of the total hang time. Okay, so again I'm going to write down our variables here. These are going to be, again, printed on your equation sheet that you'll get on the test. So if you don't remember like all of these, that's fine. Just like check the bank that's on the equation sheet. So we have all of our variables here: initial and final position, initial and final velocity, acceleration, and time. Also, I forgot to mention this question here says ENH, so this question is relevant for the easy, normal, and hard versions of the exam. There will be a question that's similar enough to this one on all three of them. So we have Mr. Vanderglass throwing a baseball. We know that this trip up and down the hang time is 6.25 seconds, which means that the trip up is going to be half of that, right? The time to rise to the peak is half of the total hang time. So the trip up is going to be 3.125 seconds, and the trip down is going to be 3.125 seconds also. Trip up, trip down, each of those are half of this time. Okay, so now let's go ahead and start filling this in. I want to look at, so we can look at this in either of these two ways. We can look at it in terms of the trip up or in terms of the of the trip down. Either of those should work fine for us. Because when you throw an object up, right, it rises, slowing down from gravity more and 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 more. Up here it stops, and then it starts to accelerate down and speeds up more and more, right? So it starts out of your hand with a speed, gets slower, 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 stops at the very highest point, and then starts speeding up, going back down towards the ground. So I'm going to say we're going to look at the second half of this fall. I think that'll make this a little bit easier. You could do this with the first half too. We're going to do this with the second half of this fall, right? So we're going to call our initial point here, where we start in the air, and we're going to call our final point down here, where we fall to the ground. Let's see. So we have our time. Our time, again, for half of this trip is going to be 3.125. Our acceleration, we're not given an acceleration of the problem. However, this is a free fall problem, right? We have an object that is falling towards the ground. So our acceleration is going to be 9.8 meters per second squared, because we're on Earth and we have an object in free fall. Our initial velocity, by the way, also at this point here, at the highest point in its arc, an object's velocity is 0. As it flies up slowly, 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 as it moves upwards, it goes from moving at a speed, getting slower, 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 stopping at its highest point, and then starting to accelerate back down towards the ground. So our initial velocity is going to be 0. Our final velocity we have no way of knowing. And we want to know what the height it raises to is, which is xf. So for this we are missing a vf. We're looking for an xf. So because we're missing a vf and we're looking for an xf, we're going to use our good friend kinematic equation number 4, which looks like this. It's xf equals xi plus vi times t plus 1/2 a times t squared. So we plug all of our numbers in here now. We get xf equals xi is 0 plus vi is also 0 times t plus 1/2 times 9.8 times 3.125 squared. 0 times t is 0. 0 plus 0 is 0. This whole thing's going to drop out. So we get xf equals 1/2 9.8 times 3.125. Half of 9.8 is 4.9. 3.125 squared. Let's find out what my calculator says that is. 9.765. I'm going to call that 9.77 because I'm lazy. So our final position down here, the height that we fall down, which is also the height that we rise up, because these are the same, right? Our final height is going to be 4.9 times 9.77. Gives us 47.87. I'm going to call that 47.9 meters. Okay, so that's how we solve that one. Hopefully these are helping you guys out. I will see you in the next one.